What if I told you that sitting in the hands of a small group of scientists in closed research institutions across Europe right now, there is data, real, verified data, collected by one of the most advanced deep space probes ever launched? Data that has been sitting in silence for 4 full months, and not a single person outside those walls has been allowed to see it yet. What would you think? This isn't some hypothetical situation. This is real, and the details surrounding it might just blow your mind. Stick around, because this is only the beginning of a story that could change everything we know about our universe. If you're fascinated by the mysteries of space, the enigma of 3E Atlas, and you want more of these mind-bending cosmic stories, smash that like button right now. Every click helps keep the search for the unknown alive. It helps to ensure that this investigation continues at exactly the moment it matters most. Because here's the thing, what's been happening behind closed doors is far from ordinary, and the story of 3E Atlas is far from over. Most people believe it is, though. After all, the headlines have moved on weeks ago, treating 3E Atlas like just another curiosity, a strange comet that came, passed, and was quickly filed away as an unusual, but ultimately explained phenomenon. But here's what you need to understand. Silence in science does not mean resolution. The silence surrounding 3E Atlas since November of last year is one of the loudest things I've ever heard. So let me walk you through the story, piece by piece. By the end, you're going to see why a meeting that's happening in late March between a select group of instrument teams could be one of the most important events happening on this planet right now. And you'll understand why almost no one is talking about it. But first, let's ask a simple question. When the most powerful deep space probe in history, a spacecraft built for studying the icy moons of Jupiter, suddenly stops doing its job and instead points 5 of its most advanced scientific instruments at a comet, what does that tell you? Think about it for a second. 5 instruments. Not just 1 or even 2 as backup, but 5 specialized instruments, all designed for very specific and technical purposes, all redirected to one object that has absolutely nothing to do with the mission's original goal. Does that sound like curiosity to you? Does it sound like routine observation? Of course not. This is a decision that something out there, something in the depths of space, requires the full attention and power of one of the most advanced space missions ever created. And that's exactly what happened. The spacecraft is called JUICE, the Jupiter Icy Moons Explorer, built by the European Space Agency and launched in April 2023. It's on its way to Jupiter, but in November 2025, JUICE was positioned on the opposite side of the Sun from Earth, a location where communications were difficult and data transmission was slow. The world wasn't paying attention, and that's when everything changed. On November 6, 2025, just 7 days after 3E Atlas made its closest approach to the Sun, JUICE's Janus camera captured 12 separate images of the object. That's right, 12 images in a single session, but that's not all. Every other instrument on that spacecraft, MAGIS, SWI, PEP, and UVS, was pointed in the exact same direction at 3E Atlas. Now, I want you to understand the gravity of what I'm describing. Because of JUICE's position on the far side of the Sun, it took a long time for the data to get back to Earth. 4 months. 4 long months of silence. And in the final week of February 2026, the full data set finally reached the research teams. So what did they do with it? They scheduled a meeting, a closed meeting, for late March. That's when the teams who built these instruments will formally sit down to discuss their findings. But think about that. 4 months of waiting, no leaks, no preprints, no public excitement, just silence. Does that sound normal to you? Because it certainly isn't. It's deliberate, structured, careful, Science does not usually behave like this unless something extraordinary has been found. You might be thinking, but science takes time. Data analysis is complex. These things require careful review. And you're absolutely right. Science does take time, and the data is complex. But there's something here you need to notice. When astronomers discovered Oumuamua in 2017, the scientific community erupted. Papers were published within days. Researchers were openly discussing their findings. The debates were heated and in real time for everyone to watch. That's what happens when something is considered just unusual but ultimately explainable. The community responds quickly, and the world watches. But when Borisov arrived in 2019, the same thing happened. Observations were shared, papers published, and conclusions were reached within months. The process was fast, routine, and efficient. But with 3E Atlas, the response has been different. The instruments on JUICE were escalated methodically. The observation schedule was coordinated with precision. The delay in releasing the data was not accidental. And now, the findings will be presented all at once, carefully vetted and shared at the same time by teams who've had the data in their hands for months. This is not the way science works when it's dealing with something ordinary. So, what exactly did JUICE observe on that fateful November day? Let's take a look at the instruments used and what they were designed to find. First up, we have MAGIS, the Moon and Jupiter Imaging Spectrometer. This powerful instrument was built to analyze icy surfaces and atmospheres. It breaks down light in both the visible and near-infrared spectrum to determine chemical composition. The team who built MAGIS spent years calibrating it specifically to study icy bodies, especially the moons of Jupiter. They know what different compositions look like when they encounter them, and when you point something like MAGIS at 3 Atlas, it's not casual observation. It's a detailed investigation into what this object is actually made of. Is it like any comet we've seen before, or does it contain something far more unusual? Then there's SWI, the submillimeter wave instrument. SWI was built to identify molecular species with incredible precision. It's designed to study the atmospheric layers of Jupiter's moons at a level of detail no ground-based telescope can achieve. But when you aim this instrument at a comet, you're not just looking for the usual suspects like water, ice, and carbon dioxide. No, you're looking for something more, a chemical signature that doesn't belong, something that could completely change our understanding of this object. Another key instrument is the Particle Environment Package, PEP. This device measures the charged particle field around the spacecraft itself. Pointing it at a comet is not routine. It means you're looking for something electrically anomalous in the region around the comet. It's not just about studying ice and dust. It's about searching for something that doesn't fit the standard model of a comet, something much stranger. So, let's step back for a moment. We have 5 specialized instruments, all built for a specific purpose. 5 instruments, all redirected at 3 Atlas, and no one has explained why. Why did this spacecraft, built to study Jupiter's moons, spend an entire observing window on a comet that has nothing to do with its primary mission? This wasn't a casual decision. Something triggered that redirection. But what? What did the team see that made them act so carefully and with such urgency? Now, before we dive deeper into what JUICE may have found, let's take a moment to talk about something else that happened during this period. Something that was reported briefly, discussed briefly, and then quietly pushed aside. As 3E Atlas was leaving the solar system, moving farther from the sun, getting colder, and losing the solar heating that normally drives comet activity, NASA's Spherex telescope detected something unusual, a flare. Not a normal brightening, not the usual increase in activity that we expect when a comet reaches perihelion, but a flare that occurred after the comet had passed its closest approach to the Sun and was moving away. This is highly unusual. Normally, as comets recede from the Sun, their activity decreases, the energy input drops, the coma shrinks, and the tail fades. But 3 Atlas didn't follow that pattern. Instead, it flared up as it was moving away from the Sun. This flare wasn't a random burst. It didn't happen by chance. It was an increase in activity at a very specific moment as the comet was leaving the solar system. Now, scientists have proposed an explanation, a heterogeneous nucleus with volatile materials that hadn't been exposed to sunlight until perihelion. This is a scientifically plausible explanation. It makes sense in theory, but it still doesn't fully explain why 3 Atlas flared up exactly when it did. Ask yourself this: if you were observing a comet for the first time and it flared up as it was moving away from the Sun, what would be your first thought? Wouldn't you think there might be something more to this comet than we understand? Something unusual beneath the surface? But that's not the end of the story. Before the flare detected by Spherex and before the imaging session with JUICE, there was another anomaly, one that was reported briefly but then quietly brushed aside. Multiple observatories detected signs that were consistent with cryovolcanic activity on 3 Atlas. Cryovolcanism refers to the eruption of volatile materials from a solid body, usually associated with icy moons like Enceladus and Triton, which have internal heat sources that drive their eruptions. This is strange. After all, an interstellar comet passing through our solar system for the first time shouldn't show cryovolcanic activity. It should be sublimating, breaking apart, or simply outgassing. But the activity observed on 3 Atlas looked structured, directed like something organized beneath the surface. Something more than just a passive response to sunlight. And yet, after these reports came out, the scientific community didn't follow up. No resolutions were made. No explanations were offered. The conversation moved on. This is not how science typically works. When a major claim is made, especially something as extraordinary as cryovolcanism on an interstellar object, it doesn't simply fade away without a resolution. So why did it? Why was this left unresolved? The silence itself is deafening. Let's move on to another strange anomaly that was observed in relation to 3 Atlas. Scientists detected an X-ray emission surrounding the comet, extending approximately 250,000 kilometers from its nucleus, about the same distance as the Earth-to-Moon distance. Now, this is significant. There's a known mechanism for cometary X-ray emissions called solar wind charge exchange, where highly charged particles from the Sun interact with the neutral molecules in a comet's coma. But the extent of this X-ray emission around 3 Atlas was unusual. It was not faint, it was substantial. This raises questions. Why was the X-ray emission so intense? What is it about 3 Atlas that is producing this unusual emission? There are still teams working to understand what happened, but for now, the mystery remains unsolved. Let's pull all of these pieces together. An interstellar object enters our solar system and behaves in ways that defy the norms. It shows signs of cryovolcanism, something organized beneath its surface. It flares as it moves away from the Sun, against everything we've seen from other comets. 5 advanced instruments on the most powerful deep space probe ever launched are redirected toward it for an entire observation window. The data from these instruments sits for 4 months, and when it's finally released, it leads to a closed-door meeting scheduled for late March, and no one has said a word. These are not ordinary details. These are not the actions of a scientific community dealing with an ordinary comet. The pattern is clear, and it points towards something extraordinary. Everything I've described comes from verified sources. The European Space Agency's own release about the JUICE data, NASA's Spherex observational reports, the X-ray detection records, these are all public. These are real. What hasn't been made public yet is the data collected by those 5 instruments. And that's the missing piece of the puzzle. It's sitting in a folder somewhere in Europe, waiting for that closed-door meeting in late March. Think about the scientists who have spent years calibrating and building these instruments, the people who have traveled across the solar system with this mission. They've had the data for months, and yet they've remained silent. That kind of discipline is not common in science. When something ordinary is discovered, the findings are shared. Leaks happen. Results are made public. But when silence like this surrounds a discovery, it's not about something ordinary. It's about something extraordinary. Something that requires careful consideration before it is revealed to the public. By the end of March or early April, we'll see papers appear, preprints posted, and official statements made. Those documents will have been carefully reviewed and crafted. They will be the polished versions of whatever these scientists found when they pointed their instruments at 3 Atlas in November. But when they release that information, I believe we'll already have a hint of what's been left unsaid. Because once you understand the silence, once you notice what's been carefully left out of the story, you'll realize that the answer to the question, what is 3 Atlas, may be something far bigger than we imagined. So, what does that mean for us? It means we're on the edge of discovery, waiting for the full truth to be revealed. Don't stop here. The universe is full of secrets waiting to be uncovered. Click on the next video and join us as we explore even more astonishing mysteries from the farthest reaches of space.